Hi and welcome to maths class. Today we're looking at trigonometry, following on from the previous video. What we're going to learn to do now is find unknown sides in a right angled triangle. So we're given a triangle and we're given an angle as well as the right angle and maybe one side. How do we find the lengths of other sides? So I've given you there on your screen, you can see a list of steps. And the first step is to label your triangle. We know where the angle is, so we label which is the opposite, the adjacent, and the hypotenuse. Then we choose a trig ratio. So we're going to go through this list. We've got sine theta equals opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So if I had a triangle and the unknown side was the opposite, and I also knew the hypotenuse, opposite and hypotenuse together, that's going to be sine. If I knew the adjacent, but the unknown was opposite, well, adjacent and opposite together, I'm going to choose tan theta. Now, in my experience, most people that get these questions wrong started out by choosing the wrong trig ratio. So take a bit of extra time to make sure you understand this step. Then we substitute the numbers that we have into the trig ratio we've chosen, and of course then we solve it and find our unknown. And we're going to need calculators, so make sure you've got your calculator handy and do the examples with me as I go. So there you can see my first two examples. So let's work through them together. My first step is to label my triangle. So there's my angle right here. We know that this is the longest side, that's got to be the hypotenuse. Then down here, this is another short side that's touching the angle, so that's the adjacent. And this is the only side that when I run my pen up and down it, I don't meet the angle anywhere, so that is the opposite side. Now, adjacent I don't know anything about and I'm not looking for it, so just cross that off. What I'm left with is O and H. And if I go back to my list of trig ratios and I look for O and H, there they are together there. So I'm looking for sine theta equals O over H. So first I'm going to write that down. Sine theta equals O over H. My next step is to substitute in all the values that I have. Now remember that theta is the angle, so the angle there is 25 degrees. Sine 25 equals, my opposite side is x, it's what I don't know, so I replace O with x, and my hypotenuse is 15. So I replace h with 15. So I'm up to now, I've done step 3, I'm just up to solving now. I need to solve this equation for x. I've got sine 25 equals x over 15. Now, one thing I really want to emphasize to you is that sine 25 is a number. It's not the number 25, but after I put sine 25 into my calculator, I'll have some decimal number. So I can add it, I can subtract it, I can multiply it and divide it just like any other number. So what I'm going to do is multiply both sides of this equation by 15 to get rid of that denominator of 15. So times 15 there and times 15 there. So on the left there, I'm left with 15 times sine 25, which equals x. This is where I grab my calculator. Turn it on. I'm going to do sine 15 times sine 25. Probably doesn't matter if I don't close those brackets, but let's do it just in case. And then I hit equals 6.339273926, and those decimals will go on forever. But we'll stop after 2. So let's go with 6.34. X approximately equals 6.34. Now, the last step that I always do is I check my triangle. Does that seem to make sense? If my hypotenuse is 15, 6.34 does seem a reasonable length for this side here. This diagram is not to scale. In fact, this looks like more than 25 degrees, but at least I know it's less than the hypotenuse. okay? And it's not an extremely different number. So that looks good to me. Let's do our second example. Now, if you want to, why don't you pause now and try it yourself, and then you can hit play and just to check how you went. So what I'm going to do first is label my triangle. There's my angle. So this is the hypotenuse because it's the longest side and it's opposite the right angle. This A runs, if I run my pen along it, it touches the 50 degrees. So that's the adjacent, and this one is left, it's the opposite, but I don't want the opposite. I'm not given it and I'm not asked for it. I'm asked to find this adjacent side here. So adjacent and hypotenuse, let's look at my trig list. There it is there, adjacent and hypotenuse together. So I'm looking at cos theta equals adjacent over hypotenuse. Write it down. Always write it down first. Apart from anything else, it's the way I signal to the person reading my work that this is the trigonometric ratio I've chosen. So then I replace the angle with the 50 degrees. Equals, adjacent is A, that's what I don't know, and the hypotenuse is 20. I multiply both sides of my equation by 20 to get 20 cos 50, which is just shorthand for 20 times cos 50, equals A. Grab my trusty calculator, clear the last answer, and do it again. 20 cos 50 equals A. I will type in the times just to be safe. 20 times cos 50 equals 12.8557. Let's go to 2 decimal places. A approximately equals 12.8. That will round up to 6, 12.86. Let's have a look at the triangle. My hypotenuse is 20. If I ever get a number on the shorter side that's bigger than the hypotenuse, I know I've made a mistake. Looks good to me. 12.86 seems like a reasonable answer. Now, don't expect whole numbers here. You will very rarely get a whole number here. You might occasionally, but very rarely. Okay, second last example. Once again, if you want to pause and do it yourself and then hit play and check your answer, that's a good way to do it, especially now you've seen 2 done already. So let's label. There's my 60 degrees. My hypotenuse is the longest side. This P is going to be the opposite because it doesn't touch the 60 anywhere. And so this 6 is going to be the adjacent. So notice it doesn't matter how my triangle is oriented, which way it's facing, where the angle is. I'm always just comparing everything to where the angle is, except for the hypotenuse, which doesn't depend on where the angle is. All right, not looking at hypotenuse, so I'm looking at adjacent and opposite. What a surprise that I've gone down to the last one that we haven't used yet. This has got O and A in the equation, and I'm using O and A here. So I'll first of all write it down. Tan theta equals O over A, and then substitute. Tan 60 equals O is P over A is 6. To get rid of this denominator, I multiply both sides of the equation by 6. 6 times tan 60 equals P. Grab my calculator. You should know how to do this by now. 6 times tan of 60 equals 10.39. P approximately equals 10.39. Now, I don't know the length of the hypotenuse in this question, but 10.39 when A is 6 looks reasonable. When I say reasonable, I just mean if I had 10,000 here, I would be worried I've made a mistake, right? It doesn't seem to fit in this triangle. All right, I've got one more example, and this one is different. But if you want to have a try at it first on your own, that's a good idea. Hit pause, try the question yourself, and then hit play to check how you went. Same steps. There's my angle. Label the opposite, label the hypotenuse, label the adjacent. The only one I'm not using here is the adjacent. So I'm using opposite and hypotenuse. So I go to my list. Opposite and hypotenuse are together here. Sine theta equals O over H. So I write down the equation. Sine theta equals O over H. Substitute sine 32, theta becomes 32 because that's my angle, equals O is 10 over H is X. Now this is where this question is just a tiny bit different from the others. If you have a look here, every time I did my substitution, my unknown was in the numerator on one side of the equation. Whoops, you can't see the last one there, right? My unknown was in the numerator. This one is different because my unknown is in the denominator. But actually there'll be lots like this. You have to get used to doing these as well. For some of you, you'll be fine. You can just go ahead and do it. But some of you will be going, oh, don't accidentally just treat it the same. What we have to do is treat it like an equation we were trying to solve. So first of all, if I was trying to solve this equation, 4 equals 10 over x, what would I do? I would multiply by both sides of the equation by x first. That would cancel these x's out and leave me with 4x equals 10. But I don't want to know what 4x is, I want to know what x is. So then I have to divide both sides of the equation by 4, leaving me with x equals 10 over 4. So that's going to be a little bit different. Let's see how that looks for the equation we've got here. Remember, sine 32 is a number, all right? In the same way that root 2, square root of 2 is a number. It's a decimal number. We don't know the size of it, although we can guess the approximate size of it, but we treat this whole thing just like a number. So I multiplied both sides of the equation by x, and that leaves me with x sine 32 equals 10. And now what I'm going to do is divide both sides of the equation by the number sine 32. I divide both sides, the sine 32s will cancel, and I'm left with x equals 10 over sine 32. I still need my calculator, so let's grab it. I'm just going to put that straight into my calculator. 10 divided by sine 32 equals 18.87. Now, have you noticed that I've been writing equals, 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 but at the last step where I take a rounded number, I write approximately equals. This and this are not exactly the same. They're very, very close, right? But they're not exactly the same. Here I've rounded, okay? So make sure that you write approximately equals at the step where you round. Also notice that what I'm not doing is calculating sine 32 separately and writing that down and then doing my division. I don't want to be rounding off at this step. I don't want to round until I'm finished. So I put this whole thing into my calculator all together and round my answer. All right, that is how we find the length of a missing side on a right-angled triangle using trigonometry.